Yeah. So what I was saying is we have two linear equation in two variables, and this is how we will write them in the standard form. Okay. This is the first one, and this is your second one. And then yesterday we had also just we saw a recap of this thing. Like if we try to plot two of these equations on the graph, there will be two straight lines. And if we have two straight lines, how many ways are there in which we can plot them? There are totally three ways. And we saw them as the three cases. Like this is the first case. If we have two lines, there is a possibility that those two lines will intersect somewhere. They will go and meet at some single point. Okay. So whenever that happens, if they meet at one single point, then we say that these two pair of linear equations, they have one single solution. They have only one solution. Okay. So yesterday I just wrote them as equation 1 and equation 2. Let me just change that today, and let me write it as a1x b1y plus c1 is equal to 0. Let's say this is the first equation, and second equation will be a2x b2y and c2 is equal to 0. Okay, so now I have plotted these two separately, and I got these two lines and they meet at one point. So there is one solution. Then there is another case that both those equations, they exactly coincide on each other. They sit on top of each other. So every point on one line is also a point on the other line. In this case, how many solutions are there? Infinite solutions. Okay. One solution, infinite solution. And then there was a third case when they don't meet at all. They are parallel to each other. In that case, there will be no solution to the pair of linear equation in two variables. Okay. All right. So what we are going to understand, we're going to understand two terms. So if we have a pair of linear equation in two variables, they can be consistent or they can be inconsistent. So let's try to understand what is that consistent and inconsistent. Okay. If I have a pair of linear equations which has any solution at all, at least one solution, that means it can have one solution or infinite solution. Okay, so do you understand this statement, guys? If they have at least one solution, means which two cases will fall under this category? Is case one consistent? Are these two equations which they meet at one point, are they consistent equations or they are not? They have one solution, right? That means they are consistent pair of equations. Same way, this has infinite solution. I said at least one solution. So infinite solution also means that this is also a consistent pair of equations. So these two cases where the pair of equations have at least one solution, they fall under the category of consistent equations. Then which will be inconsistent? Of course, the third one, because it has no solutions at all. So this is an inconsistent pair of equation. Okay, so since I said consistent, let me quickly draw the graph of these two. So this is a consistent pair of equations. If I had two lines which were on top of each other, then these types of equations are consistent. Now, what will be inconsistent? Just the opposite. Now, in this case, the graph will be parallel. Everyone understands that, hopefully. The graphs will be parallel with each other so that they never meet. See, when I'm writing these standard forms, you understand, right? It could be any equation. This equation could have been something like 2x plus 3y minus 1 is equal to 0. And if you plot that, this will be the graph of that equation. Okay, everyone understands that hopefully. Okay. So if anyone has doubt, you'll ask me. Now, I gave you these things. If you have a graph of the two equations, then you'll be able to very easily find out, right? If you have the graph in front of you and you see that they intersect or they are coinciding with each other, then you will know that they are consistent. And if they are parallel, you will know that it is inconsistent. But how do you know if you don't know the graph? Do you always have to do the graph? No. There is a shortcut way, or there is a formula to directly find out whether the equation is consistent or not. And if it is consistent, how many solutions it has. There is a formula for that. So let's learn that formula. Okay. So this will help us to find out how many solutions a pair of equation has. To know the rules, first of all, we will write the two equations. And as of now, I'm not going to write numbers. Again, I'm just going to write the two equations in the standard form, like a1x, b1y plus c1 is equal to 0. And let's say the other equation is a2x, b2y plus c2 is equal to 0. These are the two equations. Now, if I know the equations, how do I figure out directly how many solutions it will have? So that's the formula I'm going to give you right now. Yeah. So let's look at this table. This is what you need. See, if you have to look at this ratio, a1 by a2 and b1 by b2. If they are not equal, if a1 by a2 is not equal to b1 by b2, then you say that the pair of linear equations has only one solution. Okay. Pair of linear equations has only one equation, one solution. So let's take this example 4, where the two equations have been given to you. This is the first equation, second equation, and we need to check whether if it is consistent or not. So we can check how many solutions it has, and based on that, we'll decide whether it's consistent or not consistent. Now, is this in standard form already?
No, sir.
No. We need to bring the 6 and this 12 to the left hand side. Then it will be in the standard form, which we are going to follow. So let's do that. Let's rewrite these equations properly, and it will be x plus 3y minus 6 is equal to 0. And the other one will be 2x minus 3y minus 12 is equal to 0. Now they are in standard form. And now we can consider what is a1, a2, b1, b2 and all that. Okay. So what did I say? Try to find a1 by a2 and also b1 by b2 and then c1 by c2. Find all the three ratios. So what is a1 by a2, guys? Look at the a1 here and look at the a2. Tell me, what is it, guys?
1 by 2.
1 by 2.
Yes, everyone can understand that a1 by a2 is 1 by 2. Okay, so same way, what is b1 by b2? Tell me.
3 by minus 3.
3 by minus 3, which you when cancel it, it will become minus 1 basically, right? So 1 by minus 1 means it becomes minus 1. And what is C1 by C2? Minus 6 by minus 12. Okay. So minus and minus get cancelled, and this is 1 by 2. So now we have all the three ratios: A1 by A2, B1 by B2, and C1 by C2. Now let's go to the table and try to figure out which of the category it falls under. So for exactly one solution, the condition is that A1 by A2 should not be equal to B1 by B2. So is that the case over here? See, what is A1 by A2? It is 1 by 2. And what is B1 by B2? It is -1. So of course they are not equal. So we can say that since A1 by A2 not equal to B1 by B2, therefore the pair of linear equations in two variables, the pair of linear equations have exactly one solution. So if it has one solution means it is consistent, right? Can everyone understand this? Quickly confirm.
Yes,
You were
sir.
given a pair of linear equations in two variables, you found the ratios, and based on this given rule, this rule that A1 by A2 should not be equal to B1 by B2, for what condition? For having one solution. So since our equations followed this rule, therefore we can say that it has only one solution, which means it is a consistent pair of equations. Okay. Give me yes or no, guys. Everyone okay with this so far?
Yes, sir.
Yes, sir.
All right. Let's go to the second rule, which is also consistent, and it should have infinitely many solutions. What is the condition for that? You see, A1 by A2, B1 by B2, and C1 by C2, all the ratios should be equal. Okay, so these are the two equations you have. Find out the ratios, guys. Tell me what is A1 by A2. Tell me quickly. What is A1 by A2?
1 by 2, sir.
Yes, it is 9 by 18, which means it is 1 by 2. Okay, then same way, what is B1 by B2?
1 by 2.
3 by 6, which is again 1 by 2. And we see that C1 by C2, that is also 12 by 24, and that is also 1 by 2. Since all the three ratios are same, A1 by A2 is equal to B1 by B2, C1 by C2. So the pair of equations will have how many solutions? Infinite solutions. Okay, and if it has infinite solution means still it has some solution. So this is also consistent. Okay, so we learned this rule. This tells us that the pair of equations have one solution, and which means that they are consistent. If this condition is followed, what does it mean? Infinite solutions. And still, this is also consistent.
Sir, then when we'll say that it is having no solutions?
You mean the using the formula?
Yes, sir.
Yes, that is the third condition which we are getting to. See, all these three rules are written over here, page number 47 of your NCERT book. Okay, this is the first rule, second rule, and we are now seeing the third rule, when the lines will become parallel. And since the lines are parallel means they have no solution. And if they have no solution, that means it will become inconsistent. Okay, this one has one solution. This guy has infinite solutions. So for these two cases, the equations are said to be consistent. Okay, so just let me write this down in the note for you people. Third condition. A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. The first two ratios will be equal, but the third one will not be equal. Then the lines are parallel. That is, the pair has no solution. Okay. So let's take an example for that also. Can you people, just by seeing the equations, feel that now you should be able to figure it out very quickly? I am writing in so many steps and this is the first time you are seeing, but once you get comfortable with this, the moment you look at the equation, you should be able to figure out. You see, this is 6 by 2, that is 3 by 1. This is also 3 by 1. So these two pair, A1 by A2 and B1 by B2 are equal, and this is not equal to the third one. So these two pair of linear equations will have parallel lines and they will have no solutions. So A1 by A2 is 6 by 2, that is 3 by 1. B1 by B2 is minus 3 by minus 1, which is again 3 by 1. Or we can just write it as, no need to write 3 by 1, just write 3. And C1 by C2, it is 10 by 9. So what do we conclude from this? We see that A1 by A2 and B1 by B2, these two are equal, 3 and 3. But this is not equal to the third one, C1 by C2. So okay, everyone is comfortable with these three rules now? Tell me, guys.
Yes, sir.
Okay, so I'll send you some questions after the class today evening. So you will practice that and you will write both the conditions. But you'll write how many solutions it has. So I will give you a pair of equations. You have to write about the graph, whether it will be intersecting graph. Intersecting means they will be intersecting at one point. That means they have one solution. Okay. Number of solutions. What is the number of solution? Whether it is one solution or infinite solution or no solution. Any one of them. Okay. One, infinite, or no solution. And then third thing, you will also mention whether it is consistent or inconsistent. Okay. So these three things you have to tell me. So yeah, the graphs could be intersecting, or when they lie on top of each other, the name is called. So I hope everyone is able to figure this out. The three things, what the graph will look like the moment they give you the equation a1x b1y plus c1 is equal to 0, a2x b2y plus c2 is equal to 0. If you have been given the two equations, you should be able to figure out what the graph will look like, how many solutions it will have, and whether it will be consistent or inconsistent. These three things you should be able to find out. Okay. So that's it for today's class.